Welcome to part 2 of this series on chaos destruction. In this video, we're going to primarily cover the fracture tools section, and then I'll also briefly talk about some of the tools in the other sections. Links to the EPIC documentation and the project files are in the description below. So let's get started. Here we are in fracture mode with an unfractured geometry collection in the scene. If you don't know how to create a geometry collection, I would suggest you check out part 1 in this chaos destruction series. In the fracture section, you'll see we have 8 fracture tools available to us. Click on the uniform fracture tool, which we used in the previous video, and click fracture. Okay, let's go over some of the settings. I'm not going to cover every setting, just some of the most commonly used ones, otherwise this video would be way too long. There are links in the description to the EPIC documentation if you want to do a deeper dive into the tools. At the top, we have fracture level, which allows you to select the specific level you want to work with. As we apply more levels of fracture to our geometry collection, those will show up here. Explode amount, as we briefly used in part 1, allows you to visualize how the geometry collection will break apart. This can be helpful to identify specific bones that you may want to fracture further or merge with another bone. Hide Unselected is useful if you need to target a specific bone or bones without the clutter of the other bones getting in the way. For example, if we select one of the bones in our fracture hierarchy and click on Hide Unselected, you'll see only our selected bone shows in the viewport. The min and max Voronoi sites allow you to specify a random range of bones you wish to generate when you run a fracture. The default is exactly 20, which is done by setting both min and max to the same value. Let's start over and try a different value. To reset our geometry collection, go to the Generate section and click on Reset. Then click on the Reset button in the View Settings window. Click on Index 0 in our Fracture Hierarchy window in order to select our geometry collection again. Click on Uniform Fracture, and let's change the min-max Voronoi sites to 50 and 50. And then click Fracture to refracture our geometry collection. Drag out the explosion amount slider to see how that looks. Let's reset our geometry collection again. Then click on Index 0 in the Fracture Hierarchy window to select our geometry collection. Internal material allows you to pick any of the materials assigned to the original static mesh to be the internal fracture material. If you only had one material assigned to your static mesh, it will default to use that material for the inner fracture material. Here's how to add an additional material in that case. Go back to your content drawer and double-click on your geometry collection asset. Select Continue Without Data Flow. This screen allows you to access all the settings for your geometry collection. There are several material sections here, but the one we're looking for is Materials with an S, so let's type that in the search bar. The section Materials with subsection Materials is the one we want. Click on the plus sign to add another entry, and then add the material you want to use for your internal fracture material. In my case, I created a blue material instance, so I'm going to use that. Then click Save when you're done, and close this window. In order to refresh the internal material drop-down list, click on Cancel, then select the Uniform Fracture tool again. You should now see the material you added. Let's run a quick simulation to test it out. You should now see the new internal material in your fractured pieces. A word of caution here. If you add a material this way, if at any point you decide to reset your geometry collection, by default, it will remove that material you just added. To prevent this from happening, with the Reset tool selected, you want to unselect Reset Materials before you click on the Reset button, Geometry Collection. Then click on Index 0 in your fracture hierarchy to reselect your geometry collection. Let's continue on with some of these other settings before we refracture our geometry collection again. Random seed. Changing this value causes a new random Voronoi pattern to be generated. The default value is -1, which means Unreal will randomly select a new pattern each time you make a change to your fracture settings before you actually fracture it. Let that sink in for a minute. Anytime you make a change to your fracture settings, your Voronoi pattern changes. Click on Internal Materials again, and this time select Automatic, and keep an eye on your viewport when you do so. Your Voronoi pattern changes. Now click on your geometry collection in your viewport. Your pattern changes again. For me, this is a very undesired effect, especially if you have a pattern you like, then accidentally click on your geometry collection or change a setting. Here's the workflow I follow and suggest you do so also. The first thing I do anytime I start to perform a new fracture is I go to the min-max Voronoi settings and put in how many sites I want. Then I go to the random seed setting and find a Voronoi pattern I want by trying different values. Once I have a pattern I like, then I can proceed to doing whatever I need to without the concern of losing the pattern I selected. Grout. This adds a grout line between your fractures and is measured in centimeters. The default value is 0, no grout. Let's try a value of 10, then click Fracture. It's somewhat visible if you have bone colors enabled, but it really shows up once you explode your geometry collection via the slider. Draw a diagram. This toggles your fine wire fracture guides on and off. Draw noise preview. This toggles the gray fractured pieces on and off. Those gray fractures are there to help you visualize any noise you may apply to your fractures. But before we check that out, let's reset our geometry collection and make sure Reset Materials is not enabled before you click the Reset button. Click on Index 0 to reselect our geometry collection. This section allows you to add some bumps to your fractured edges, which can help them look more natural in certain situations than the default straight edges. Amplitude controls the magnitude of bumps, and frequency seems to spread the noise pattern out along the fractured edges. Good starting values are 5 and 1. The noise section is common to the other fracture tools and works the same across all of them. Let's reset our geometry collection before we move on to the next fracture tool. Click on the Cluster tool. The Cluster tool is similar to the Uniform Fracture tool in that they both create fractures based on a Voronoi pattern. Whereas the Uniform tool tends to spread the Voronoi cells out somewhat evenly, the Cluster tool will create concentrated patches or clusters of cells within the pattern. Min-max num clusters. This controls the number of clusters in the pattern. Setting these to the same value sets a fixed number of clusters versus a random number within the min-max range. Min-max sites per cluster. This controls how dense each cluster site should be. Higher values mean more fractures within each cluster. Min-max distance from center. This controls how far from the center these clusters should be. The other settings should look familiar to you, since they are the same ones from the Uniform Fracture tool. And like the Uniform Fracture tool, my workflow recommendation applies here also. start with a non-negative 1 seed value first, then adjust all other settings afterwards. Using the default values, let's run a fracture to see how it looks in the exploded view. Let's reset our geometry collection once again, then make sure it's selected. Click on the Radial Fracture tool. By default, it aligns along the Z-axis. Another issue is that the gizmo to adjust the fracture transform sits on top of the transform gizmo for the geometry collection itself, so it can sometimes be impossible to try to rotate the fracture guide without moving the geometry collection. If you run into this same problem, here's a way around it. The normal settings allow you to input transform values, but it's disabled by default. To enable it, scroll down to Placement Controls and uncheck Use Gizmo. Values are 0 through 360, so a value of 90 for the x-axis should orient the fracture guide correctly. Also set the Z value to 0. It defaults to 1 for some reason. As you can see, this creates a fracture pattern common to glass. Let's review some of the settings. Angular steps. This controls the number of radial lines outward from the center. Angle offset. This allows you to rotate the position of the radial lines. Radius controls the maximum size of the concentric rings. Radial steps are the number of concentric rings, starting with 1 being the center point. Radial Min Steps is the minimum space in centimeters between each ring. Let's fracture and explode this out to see how it looks. Once again, let's do a reset and make sure your geometry collection is selected. Click on the Planar Fracture tool. This is a simple tool that performs a single, infinite knife-like cut for your geometry collection. As with the Radial tool, its gizmo can sometimes be next to impossible to transform. And to make matters worse, there is no numerical input for this either. The workaround is to transform your geometry collection actor into the position you need for the cut. Once again, let's do a reset and make sure your geometry collection is selected. The Slice and Brick tool do pretty much what you would expect, and I'm not going to cover them now since this video is running long as it is. The Mesh tool allows you to do Boolean cuts using another mesh as your cutter. And Custom allows you to customize your cutting tool as needed. Before we end this tutorial, I just want to briefly go over some of the other tools in the Fracture Mode collection. The Select section contains tools to help you navigate your fracture hierarchy and is especially helpful when you have multiple levels of fracture. Most are pretty self-explanatory. The ones I tend to use the most are Level, which selects all bones at the same level as the currently selected bone, and Interactive, which allows you to do a drag select in your viewport. This is very helpful when paired with Hide Unselected. The Edit section contains tools to allow you to hide, delete, or merge specific bones. The Cluster section contains tools to help you group selected bones into a single cluster and to manipulate existing clusters. The EMBED section allows you to take external static meshes and embed them within specific fractures of your geometry collection. In the Matrix Awakens demo, specifically the road collapse clips, that's how they added the rebar to each fracture of the bridge road. I'll leave a link to how they made that in the description below. The Utilities section contains tools to help fix UV issues, collision issues, etc. But the one I use the most is TinyGeo. Based on the parameters you specify, it will look for tiny fractured pieces that really wouldn't be noticed in the simulation and are just taking up needless resources, and merges them into a neighboring bone. This is a great tool to use to help optimize your geometry collection. And that concludes part 2 of this tutorial series on chaos destruction. If you found this tutorial helpful, please hit that like button and subscribe to the channel. In part 3, we will be covering field systems, which generate forces to induce damage to our geometry collections. This is where it gets exciting, so I hope to see you there.